Okay, I just wanted to give you some examples of putting everything together leading up to 3.4 before we start 3.5. So in this example, we have a degree of 3, which means that the left and right hand behavior is going to be opposite. Leading coefficient is positive, which means right hand goes up, left hand goes down. But I want you to notice something. I have a 1 and a 2 and a -4 and a -8. I don't have to do synthetic division for this one, okay? Um, there's a pattern. I've got 4 pieces. I can group 2 together and factor out the common factor, then look at the back 2, factor out the common factor. You always take that sign out. When I pull a minus out here, I get a plus. Now my blobs are the same, so I can factor the blob out. That leaves me with x squared minus 4, which then factors as x plus 2, x minus 2. Notice that I have x equals -2 twice, okay? So I've got x equals a -2 and x equal, I'm sorry, this is the twice one, -2 twice and a +2 once. Find your y-intercept by plugging in zeros for the x's. Like I said before, right hand is up because the positive leading coefficient. Left hand is down because it's an odd power. Y-intercept is down at -8. Mark your x-intercepts that you found by factoring. Remember, x-intercepts are where y equals 0. Plot those. Notice that the one that's double has special behavior, right? Multiplicity 2 means that it behaves like a parabola in that area. Okay, first thing you need to notice about this problem is that I go from x cubed to x. I'm missing the x squared term. That means that when I set up my synthetic division, I have to put a 0 in the x squared column. All right, degree is odd, left and right hand behavior is opposite, leading coefficients plus, so right hand is up. X equals 0, y equals 6. Possible zeros are the factors of the last number divided by the factors of the first number, which we don't see often, but we have to allow for that there may be some fractions. This is a 1, so all of my possible zeros are just the factors of 6. All right, don't forget to put the 0 in for the x squared column. First thing I'm going to try is the 1, but wait, I don't have to do this to see if 1 works. I can just add the coefficients, right? If x is 1, then all of these x's, no matter what the power, they're just gone, and we have the coefficients. Does this add to 0? 1 minus 7 plus 6 does equal 0, so 1 works. What does that mean I'm going to do? If I know 1 is a 0, I'm going to go ahead and pull it out. If I can pull off one of the factors of this thing, I'm going to be left with something simple. You bring down the first number, multiply, you've got that process down, you should, okay? This leaves me with a remainder of 0, the coefficients of what's left. We started with x cubed, so this is x squared. Factor it, set the factors equal to 0. Now I have all of my x-intercepts. I'm crossing up here at y equals 6. I have a 1 and a 2 and a -3 on my x-axis, left and right hand behavior, so I'm starting from below and going straight up through that 0, passing through the y-intercept, passing through the 2 x-intercepts. They're all multiplicity 1, so they behave as straight lines when they pass through the zeros. All right, for this one, we have 4, 3, 2, 1, 0, so we don't have to fill in any columns. Left and right hand behavior is the same. Leading coefficient's positive, they're both up. Y-intercept is minus 18 because all of these x's will be zeros. Possible zeros are the factors of 18 divided by the factors of 1. So I have 1s, 2s, 3s, 4, 5, 6s, 7, 8, 9, and 18s. These big ones you don't have to worry about. You're going to get your zeros early. So first I want to write down my coefficients. Then I want to check and see if the coefficients add to 0. If they add to 0, then 1 it'll work and I can pull off a factor. So this is negative 10 and negative 18. That leaves me with minus 28. Positive 28, 1 works. So do the process. Bring down the first number, multiply, write it down and add, multiply, write it down and add. You should know this process by now. Multiply, add, multiply, boom, I got a 0. And I knew that. Now look at the pattern. 1 and 2, opposite signs. This is double this, opposite signs. I can factor by grouping. This guy was x to the 4th. That means this guy is the coefficient of x cubed. Factor the x squared out of the first two. Always pull out the minus. That makes this a negative. Blobs are the same. I'm left with x squared minus 9, which factors. I have x minus 2 and x plus 3x minus 3. That gives me all of my zeros, positive 2 and plus or minus 3. I'm going to plot my y-intercept at minus 18 and my x-intercepts at 1, 2, 3 and negative 3. No multiplicity issues. I'm passing through with a straight line and I'm up on both ends. So I'm going to pass through like a straight line, turn around, sorry I'm off the page, catch that y-intercept, pass through, pass through, pass through, and don't wobble. Make it nice and smooth. So this stuff is pretty easy when you break it down into the steps. Once you get your coefficients written down, add them together. If it equals 0, you plug in a 1, you get the coefficients of what's left. If you have 4 pieces, you always check to see if there's a pattern. Can you factor by grouping? Yep, these two I can factor something out. These two I can factor out something, and my blobs are exactly the same. You cannot do this unless your blobs are exactly the same. That means I can pick up my blobs and throw them out front. Who's left in my house? The x squared and the minus 9. Make sure you understand that. All right, we have a different situation than we've had before. My leading coefficient is negative, which means my right hand is down. Degree is odd, so left hand is the opposite. But my possible zeros are going to be fractions. I'm going to start with the factors of 3, which is going to give me plus or minus 1 and plus or minus 3. But all of these factors have to be divided by all of these factors because I may have had a blob that had a 2x minus a number. If you set that equal to 0, you're going to get a number divided by 2. That's why you have to do that. All right, set up your long synthetic division, Always start with the 1. Do these guys add to 0? No, they don't. That means positive 1's off my list. I'm going to start with the negative 1. This is not always a 1, guys. Pull it straight down. Multiply and add, multiply and add. Multiply and add, I got my first 0. So x equals negative 1 is one of the x-intercepts. This is quadratic. When you get down to 3 numbers, you stop. By the way, we checked at the beginning to see if we could factor by grouping. That 3 messed me up. All right, so I multiply both sides by a minus. That's still a 0, but it gets rid of this guy. Don't forget, you got to change all of your signs. Now, the way this is factored, 2 times 3 gives me a 6. The factors of 6 that subtract to be 1 gives me a 2 here and a 3 here. You better know how to factor at this point. This gives me 3 halves. This gives me -1. Notice that my -1 is double, so that's special. I'm going to look like a parabola there. Y-intercept at 3. I have another x-intercept at 3 halves, which is 1 1/2. My right-hand behavior is down. My left hand is up. And I'm going to just touch and turn around because of multiplicity 2. Pass through this guy like a straight line. And it's that easy, y'all. All right, big, long, nasty one with big numbers, but I want you to notice something. All of these are pluses. If all of these are pluses, the only way this equals a 0 if I have a combination of positive and negative, right? So if all of these signs are the same, all my zeros have to be negative. That cuts my list of possible zeros in half. So even though I'm talking about the factors of 104, at least they're all negative. I know that, right? So same behavior left and right, both up. Y-intercepts at 104. I'm not going to count out 104 on the y-axis. I'm just as lazy as you are. Possible zeros will be the factors of 104 because this guy's a 1. So watch what I do over here. I've got to get all the factors. So I'm going to pull out a 2. So I've got a 2 on my list and a 52 on my list. If I divide that by 2, I got a 26 on my list. Divide by 2 again, 2's already on my list. I get a 13. So I'm going to get a 2 times a 2, oh, the 1, by the way, and the 2 times 2 times 2, and I got a 13, a 26, and a 54. So those are all the possible combinations of numbers that multiply out to be 104. We're not factoring it completely, we're listing all possible factors. So this guy right here gave me a 4, and this guy right here gave me an 8. See how that works? And they're all negatives. All right, so I'm going to put in the -1 first. I have a 4, 3, 2, 1, and a constant, so nothing's missing. I don't need any zeros. Just copying down my coefficients. Same process, pull the first guy down, multiply, add, multiply, add, multiply, add, multiply. It takes me a long time to, that's not going to work. Forget it, right? Because I'm multiplying by a 1. There's no that way. That's going to be 104. Moving on to the next number. If I had continued, I would have gotten a point on the graph. But yeah, whatever. So here we go. Pull down the first guy, multiply, add. I have high hopes for this one. Add 29. Double that with a minus sign, 58, add, ooh, I get a 52. Multiply that by 2, I get -104. I found my first 0. I'm going to make a list. Now I want to try the -2 again. You always try it again because it might be a 0 with multiplicity 2, correct? So you copy these numbers down again, or you just put your little box right here and you continue to work. Okay, -2 in the box. Never, ever, ever go back to the original numbers. You don't want to solve the same problem more than once. You pulled off a factor right here, so you want to use these values. Pull it down, multiply, add, gets 17. Multiply 17 by 2, and I don't get 52. So I move on to the next number in the list, which was a -4. Notice that I do not go back to the original numbers. I go to the numbers where I got a 0. Bring down the first number, multiply, add, multiply. Ooh, 13 times 4 is 52. And I got another 0. And now this is quadratic. So I got my -4. I got my -2. Two zeros here. And now this is x squared plus 4x plus 13, which doesn't factor, and that's okay. I'm going to complete the square. My leading coefficient is a 1, and my middle guy is even, so divide him by 2, write it down, square it, add it to both sides. This is now a perfect square, x plus 2. This is going to be -9. Notice that I have a square equals a negative number, which gives me complex answers. Square root both sides, don't forget plus or minus, and don't forget the I because you're taking the square root of the negative. Move this 2 over to the other side, and I get 2 complex zeros. I can't graph these. It just indicates that there's something going on with my graph. I'm going to list it because I'm finding all of the zeros, real or complex, and only graphing the real ones. All right, so here we go. These guys just show me that it wobbles somewhere. I have a 0 at -2, at -4. I have a y-intercept way there up there at 104. My left and right hand behavior are up on both sides. Passing through those zeros, picking it up. There's a wobble somewhere. I don't care where you put it. You don't even have to put it if you don't want to. And there you go. Practice, practice, and good luck.